Basic is kind of investigating a disease state, and I'll give my example. So my research interest has been in venous thrombosis, which is basically a clot in the deep veins of the leg. People probably heard of commercials for certain blood thinners that are, someone who's had a DVT blood clot is how they term it in the commercials. So it's a common problem. It can be fatal. There's not a lot of surgeries for it, although there are some catheter-based techniques to get rid of the clot, but typically it's treated medically. What do I mean by treated medically? It's treated with anticoagulation, elevation, compression, that type of thing. And so with that, the basic part of that is just investigating, usually in animal models. There's other models as well. What are the cells involved? What are the factors involved in this type of thing? And a lot is known, but a fair bit isn't known, especially with some of the abilities to get into the cellular specific RNA transcripts, for example, called transcriptomics, just to define really what's going on, much more in detail than they could do 10 years ago. So that's kind of the basic science part of it. Translational science is looking at, well, what have we identified as a pathway that could potentially have a pharmacologic agent or something that then you could modify the response to get a better outcome. So give another example. So one of the things after the vein is in contact with the clot, the vein wall gets inflamed, so it gets irritated, so to speak, and you have a injury response, which is scar tissue. And so looking at the pathways that drive that, and then looking at potentially an agent that could target that scarring to reduce it, that's a goal with translational work, at least in my lab.